Okay, next in the second recording, we're going to discuss the in section 5.2 oral doses. So we're going to be determining pediatric doses using dosing tables. Talk about dispensing liquid medications, and then we're also going to talk about calculating the amount to dispense. So oral medications, of course, are prescribed over other dose forms whenever possible because usually they're more safe and cost effective. And the liquid medications are most commonly used by children and by adults who have difficulty swallowing solids. So, of course, not all drugs that are safe and effective for adults use are going to be appropriate for the pediatric population. So a manufacturer, of course, needs to provide and will provide specific age or weight related prescribing guidelines for pediatric appropriate doses for medication, and that is only as soon as it is considered safe and effective for a pediatric population has been established. So these guidelines are going to be provided in what we refer to as closing table or dosing tables. So the dosing tables, of course, are going to be used to determine the dose forms for young patients. Such tables can provide an age range and or weight range with the corresponding dose. This is a definition of dosing table. Dispensing liquid medications. Many liquid medications are actually solids suspended in a liquid. So it is indicated, of course, by the number of milligrams per milliliter. Usually, an oral liquid medication's written prescription will include a specific volume to be given at each dose and a total volume to dispense. This right here is showing you a dispensing liquid medications. It's showing you the oral syringe. Of course, it's going to be marked with both household measurements and metric units. So if you notice, the household measurements are written in teaspoons, and they are written in green up this one side. And then, of course, the metric units are written in red. It is written in milliliters going up this side. And if you notice, it does break it down into like 9.2. So it is to be more accurate. So the pharmacy receives, this is an oral dose example, the pharmacy receives a prescription for 100 milligrams of amoxicillin to be taken 3 times daily for 10 days. The pharmacy has 150 milliliter bottle of 125 milligram per 5 milliliter, and that's where you have it here on your label, of amoxicillin. How many milliliters of the suspension will be dispensed, and what will the patient's dosing instructions on the label say? So if you look at, anytime what I do when I'm working a problem is I always, if I can set it up in a ratio proportion, I do. Then, if I need to convert, I will. Okay. So if you look at here, you have the X milliliters. That's what we're trying to find over your 100 milligrams of amoxicillin. And then, of course, it comes in 125 milligrams per 5 milliliters. And that's where we get our numbers here. Okay, if you notice on both of the bottom, they have weights, and both weight units are the same. So we're good there. On the top, you have the liquids, and they are both milliliters, so they're both the same unit. So what we need to do next is what they did is they cross multiplied. Whatever you multiply the X by always goes on the bottom. So it'd be 125 on the bottom. And then 5 times 100 would be 500, and it would go on top. Okay, and then when you divide 500 by 125, you will get your 4 milliliters. Okay, next part of our question, it says, what will the patient's dosing instructions on the label be? Of course, it's going to be, first we need to figure out how much they need to take. So using the amount determined for a single dose, determine the total amount of suspension to be used for the 10 days. So if they're taking 4 milliliters, which we figured out on the last slide, and they're taking it 3 times a day, okay, for 10 days. So it's 3 times a day. So we're going to have 3. And then it's for 10 days, so you're just going to multiply it by 10, okay, to get that metric quantity. So 4 times 3 is 12. 12 times 10 is 120. So they're going to need 120 milliliters total. Okay. Next, what will the, if you was to write on the, type out the label, what would it say? For, it would say, of course, take 4 milliliters 3 times daily for 10 days. So the amount to be dispensed is calculated by multiplying the amount of the drug needed for a single day by the number of days of treatment needed for the reason why you need to figure out the day supply a lot of times is if you're inputting a prescription into the computer and the patient has insurance, the insurance company is going to stop you and ask for the day supply. Also, it is also needed to confirm patients can complete the treatment. So here's another example. A patient is to take 1 teaspoon of medication twice daily, and she has a 4-ounce bottle of medication. How much medication will the patient take in a day, and how many days will the medication last? So first, we'll figure out the first question. How much medication will the patient take in a day? So you want to begin by converting all of the stated volumes to the metric system. So just remember 1 teaspoon equals 5 milliliters, and 1 ounce equals 30 milliliters. So to determine how much medication the patient is to take daily, what I do is I usually convert everything to milliliters. So the 1 teaspoon, like we said, and if you want to write it on your question, you can make it, a little bit easier. 1 teaspoon equals 5 milliliters, and your 4 ounces is going to equal 120 milliliters. Okay, so how much medication will the patient take in a day? So if they're taking 5 milliliters twice a day, you would just do 5 milliliters 2 times a day. I don't know why I wrote 10. 2, so 5 times 2 is going to be 10. So it'll be 10 milliliters per day, so that answers your first question. And then, I think I have them separated on different slides here. You want to know how many days will the medication last? Well, we know we have 120 milliliters. So this is from the previous question. We've already done 10 milliliters a day. And then to determine the day supply, so you know you have 120 milliliters in a bottle. That's where we get that. And we have 10 milliliter, taking 10 milliliters a day. So all you do is you take your 120 and divide it, of course, by your 10. Would be the easiest way to just do it. And it comes out to be 12. So that bottle will last them 12 days. Now what they have done is they've set it up kind of in a ratio proportion, but you do not have to do it that way. You can just, sometimes I think some things you can figure in your head, like basic division and multiplication, and it's okay to do that. But you need to be careful doing that as well. Until you get used to it, you may want to set it up in a ratio proportion. But I do, when I teach this class, I try to teach you little shortcuts as we go through, but you can always fall back on the ratio proportion if you have 3 of the numbers in trying to find the 4th. So how might a prescriber write a 1 teaspoon of a medication twice daily on a prescription? It would be 1 TSP for teaspoon, Q for every, 12 for 12, and then H for hours. How might a prescriber write 1 teaspoon of a medication 3 times a daily on a prescription? Again, you would write 1 TSP for teaspoon and TID for 3 times a day. Okay. So now we're going to look in your book and we're going to go through and do some examples. Now section 5.2. And this is on page 134 in your book. So if you flip to 134, And look on question 29. You're going to use this label to answer the questions, to answer question number 29. So a mother has 2 children with poison ivy. One child, and I'll put child 1 is going to take 1 teaspoon 3 times a day. Child 2 is going to take 2 teaspoons 3 times a day. Okay, so how many bottles of this diphenhydramine elixir will be needed to supply both for 4 days? So again, both of these are going to be doing it for 4 days. So I'm going to put 4D for days. Okay, so what I do is I would convert these over to milliliters. You have 1 teaspoon is 5 milliliters. And you have your TID 3 times a day. We just put our 3 here. And then we have our 4 days. Okay. This one, 2 teaspoons is 10 milliliters. You're going to do it times 3 times a day, times 4 days. Okay. So if you take your calculator and you have 5 times 3 times 4, that gives you 60 milliliters. Okay. Child 2 is going to take it 10 times 3 times 4, be 120 milliliters. So child 1 needs 60 milliliters and child 2 needs 120. So you want to add those two together because it's asking for how many bottles they're going to need for both children. So 120 plus 60 would be 180 milliliters. Okay. So that she needs a total of 180 milliliters to make sure that both children have enough medicine for 4 days. So if you look up here in your label, it states that you have 4 ounces. Well, 4 ounces is 120 milliliters. So how many bottles would you need? Well, you need 180 milliliters, so you're going to need 2 bottles. And yes, she'll have some left over, but she'll have enough. Because it does ask, how many bottles. It doesn't ask for how much. So how many bottles will be needed to supply both children for 4 days. So she would need 2 bottles. Okay, next, if you look in your book on page 134 at question 31, we're going to be using this Cephalacor label to answer the question. It says, how many milligrams are in 3/4 teaspoon? So we're trying to find X milligrams in 3/4 teaspoons using this medication. So this you could actually set up in a ratio proportion. So we know this is our given, so I'm going to go ahead and put it first. I'm going to put the milligrams, the weights on top. It doesn't matter what you do, as long as when you multiply the X by it always goes on the bottom. 5 milliliters. Okay, so that's where I got from your label. And you're trying to find X milligrams. So if you have weights up here and it's milligrams, you want to put it on the top as well. Okay. And then you're trying to find it in 3/4 teaspoon. So if I have liquids down here, I'm going to put liquids here. Okay. But our liquid units do not match. So what we need to do is we need to convert our teaspoons over into milliliters so both units will match. So what I usually do is I just go over to this side and I put, I divide first. 3/4 is going to be 0.75 because you want to put that into a decimal form. So you have 0.75 teaspoons. If you have teaspoons there, you need teaspoons down here. And you want milliliters, and you know that there's 5 milliliters in 1 teaspoon. So then you just multiply that out, and you should come up with 3.75 milliliters. So this one we have converted to 3.75 milliliters, and now both of our milliliter units on the bottom match. So now we're going to cross multiply. X times 5 is 5x. Then you have, of course, 187 times 3.75, and it should come up with 701.25. Okay, then when you divide 701.25 by 5, your answer is 140.25 milligrams. So in 3/4 of a teaspoon, you will have 140.25 milligrams of the medication. Okay, next we're going to look at number 32. Okay, which is on the same page. It is on page 134. And number 32 is using that same label of the 187 milligrams per 5 milliliters of the Cefaclor. And it says how many milligrams would be in 1.5 teaspoons. Okay, so that's what we're trying to find. So remember our Cefaclor label. It said we had 187 milligrams in 5 milliliters. And we're trying to find X milligrams. And we have 1.5 teaspoons. Okay, so what you want to do is that you want to convert that over into a decimal. So your decimal would be 1.5 teaspoons for 1.5. And then we're going to convert that teaspoons over to milliliters so our units will match on the bottom. Again, 1.5. You have teaspoons here, you'll have teaspoons here. And in 1 teaspoon, you have 5 milliliters. So 1.5 times 5 would be 7.5. Okay, so this is converted to 7.5 milliliters. And all you're going to do is cross multiply. 5 times x is 5, it goes on the bottom. 187 times 7.5 would be 1,402.5. And when you divide that by 5, it comes out to be 280.5 milligrams. Okay, next we're going to backtrack, and I'm going to go to page 133 and do question number 11, just to give you one that we set up in a ratio proportion, and then we have to convert again. So if you look at number 11, it says if there are 24 milligrams in a teaspoonful of liquid medication, how many grams are in 8 fluid ounces? So remember, it says, if something says a teaspoonful, that means 1 teaspoonful. Okay. So our known is 24 milligrams in 1 teaspoon. So I have weights on the top. So it's trying to find how X grams. So gram is a weight, goes on top. And 8 fluid ounces is a liquid, so it would go on the bottom. Okay. So if you look here, we have weights on the top and liquids on the bottom, but none of the units match. Okay. So first thing that I would do is you're trying to find X grams, so you need to make this milligrams grams. So we're going to take 24, and I'll doodle on this side of the board to get your conversion. So we're going to take 24 milligrams, and we need to convert it over to grams. If you have milligrams here, you have to have milligrams down here. So you have, if we remember your chart, milli means 1,000. If it's 1 unit by itself, when it comes to grams and all that, it's 1. So 24 times 1 is 1, divided by 1,000. Okay, and you should come up with 0.024. So that's what would go over here. So we're going to take that out, and we're going to make it 0.024 grams. Okay, so now our units on the top match grams and grams. On the bottom, our units are in teaspoons and ounces. Our liquids are. This is where I was telling you that just converting over to milliliters when it comes to the liquids is much easier because we could do it in our head. 1 teaspoon is 5 milliliters. If you have 8 ounces, you times it by 30, 8 times 30, and you should have 240 milliliters. Okay, so now both our units on the bottom match, and they are in liquids. Okay. The only time when you can't do that is when you're finding a specific x. So now we're going to take this out, we're going to take this out, and we're going to cross multiply. X times 5 always goes on the bottom, so it'll be 5. 0.024 times 240 is going to be 5.76. Then you take your 5.76 and you're going to divide it by your 5, and you should come up with 1.152 grams for number 11. And that is all for section 5.2. I will record the next one on our last one for this chapter on section 5.3.